This is the OFI testing equipment, Garrett gas train, for measuring the amount of hydrogen sulfide gas and carbonates. It is portable. We sell it with the portable carrying case, which is this device here. And in the carrying case is all the Draeger tubes, the measuring devices for measuring H2S and carbonates, the hand vacuum pump, which we'll do when we run the carbonate test, as well as the octanol defoamer, the hydrogen sulfide detection tubes, the sulfuric acid, everything that you need for running this Garrett gas train test for both carbonates and hydrogen sulfide is in this carrying case. So basically, this is just an introduction to what the gas train does. It is the most widely used portable instrument, as I said, and it measures the presence and quantity of soluble sulfides and carbonates concentrations in a drilling fluid. Soluble sulfides includes hydrogen sulfide as well as the sulfide ion and the bisulfide ion. Total soluble carbonates include carbon dioxide as well as the carbonate ion and the bicarbonate ion. You can also get carbonates and bicarbonates by running alkalinity test. Now, that is a titration procedure. And as with all titration procedures, if you see the end point and can get a good color change, then it's reasonably accurate. But the Garrett gas train is much, much more accurate as far as determination of alkalinity, bicarbonates, and things of that nature. So basically, we put our mud filtrate in chamber number 1, and it has to be filtrate. We cannot have solids in the solution. We do have, that we sell as a separate item, a oil mud analysis test for hydrogen sulfide, and on that test you can have whole mud or solids in the fluid. But for the standard H2S and carbonate test, it has to be filtrate. It has to be a solids-free solution. So you put your filtrate in chamber number 1, you acidify it with a 5-normal sulfuric acid solution. That acid solution basically drives the soluble sulfides out of solution, forming hydrogen sulfide gas. We use CO2 bulbs to pressurize, and we apply roughly about 15 psi, something like that. It's not very much. It's a small amount of carrier gas. It flows through what we call a dispersion tube. It's in chamber number 1. Some people call that a fritted disc because it looks like so, and on the bottom is a filter which strains out the particles that may be trapped in the line somewhere, and then we get into solution. So the carrier gas bubbles out of that, and the acid that has driven the H2S out of solution flows out of chamber number 1 into chamber number 2, and eventually through what we call a Draeger tube that's next to chamber number 3. These Draeger tubes can be purchased in varying sensitivities. You can get them for chloride, you can get them for calcium, you can get them for lots of different types of ions and for chemicals. But basically the ones that OFI sells are 2 ranges. We have a low range H2S tube, and we have a high range H2S tube. And you have to have an idea roughly to begin with what your hydrogen sulfide concentration is. H2S gas, as far as being poisonous, lethal to people, can be very, very one of the worst things a person can encounter on a drilling rig. as little as 10 parts per million. If you breathe enough of it, potentially could kill a person. The insidious part of it is that above 10 parts per million, you can't smell it, which makes it even more dangerous. Below 10 parts per million, you get the classic rotten eggs smell. It smells very bad. But as long as you can smell it, you're reasonably safe. If you got a whiff of 1,000 parts per million, you would probably be unconscious pretty much immediately. So for that reason, we concentrate mainly on the low end of H2S, but we have both ranges. The low range tubes are marked 100/1, and the measuring range on that is 100 to 2,000 parts per million H2S gas. The high range tubes are marked 0.2%/A, and the range on that is percent by volume. It's a 0.2 to 7% by volume. That's a lot of H2S. That's a lot of hydrogen sulfide. That's not something that you'd want to get involved with personally without some kind of a gas mask or air pack on your back. The Draeger tubes for the carbon dioxide, which we will run later, are marked 0.01%/A, and the range on these is 0.01 to 0.3% by volume. I have an example here of the Draeger tubes. These are the low-range H2S Draeger tubes, and this is the high-range H2S Draeger tubes. And these are marked. There is also an arrow on here that indicates the direction of flow. So you want, when you put it in here, you want the arrow to be pointing down. And the amount of H2S or hydrogen sulfide in this particular Draeger tube, the amount will stain down the length of this low-range Draeger tube. I just ran a test. I had what we're using is we're using a sodium sulfide solution in the lab to supply the sulfides, the soluble sulfides in solution. And I had actually too much of the sulfide in solution because it pegged out the low-range tube, but hopefully you can see the difference. Here is a unused, unstained tube, and here we've actually stained this one, the entire of the tube, which shows that we've got this is like 2,000 parts per million, but it's a small quantity, fortunately. But essentially, that's the way this test is run. You apply a minimum amount of pressure here. You drive the gas out of solution with your sulfuric acid. You flow across the gas train, and then flow your gas through your hydrogen sulfide gas through the H2S Draeger tube, and from that you get a determination of the amount of H2S gas that is present. So essentially, that's the way this test is run. The reason for running this test, hopefully, is clear to everyone. And again, this is the main way of testing hydrogen sulfide in the field. It is extremely accurate. It is using these Draeger tubes. One other thing I might mention, there is a qualitative test that you can run using lead acetate paper disc. Instead of, in chamber number 3, instead of using a Draeger tube, you can put this lead acetate disc on top of your chamber, and lead acetate in the presence of hydrogen sulfide will turn dark. If a lot of hydrogen sulfide is present, it will turn black. If a smaller amount is present, it will turn brown. And when I say large or small, I'm talking about 50 milligrams per liter, or 50 parts per million. In testing for sulfides, H2S, we equate milligrams per liter is equal to parts per million. So with these lead acetate paper, or hydrogen sulfide test papers as some people call them, you can get up to about 50 milligrams per liter, 50 parts per million. And this will tell you if sulfides are present in solution, and if you do get a positive with this, then you would run your test with your Draeger tubes. And that will give you a quantitative test, the amount of hydrogen sulfide presence in milligrams per liter and or parts per million. So basically that's the introduction for this. In part number 1 of the test procedure, we're going to run an H2S test with using the sodium sulfide solution and a Draeger tube sensitive to H2S gas. So I thank you for your attention.